All right, so for this video, we're going to be talking about planetary boundaries, what they are, and talk a little bit more in depth about one of these planetary boundaries. So basically, as you can see here, we've got 9 planetary boundaries, and we got green, yellow, and red zones. So basically, this green area is below a boundary, which means that it's safe, or these levels aren't getting too high, and we can kind of predict what's going to happen. In this yellow area, that's when we start to get into uncertainty as to what's going to happen. It's not as predictable. And then in red here, we have beyond the zone of uncertainty. This is where it's really bad. We don't know exactly what's going to be happening within these planetary boundaries. So we're going to talk a little bit more in depth here with the ocean acidification.
Ocean acidification occurs when carbon dioxide is absorbed by ocean water, which greatly reduces pH levels. Calcium carbonate minerals make up skeletons and shells of several oceanic species. Because of oceanic acidification, many of the minerals that are present within these shells and skeletons are not present, which in turn affects habitual behavior and ability of these animals. Significant future projections predict that oceans will become more and more acidic. Surprisingly, photosynthetic algae and different types of seagrass would benefit from higher CO2 levels. However, since shelled species are being harmed by the rising acidification level, the whole food chain will be affected, since shelled organisms not only feed many species of fish, but also clean areas such as coral reef. The rising CO2 affects humans who work in the fishing markets because pertaining to shelled organisms, entire oyster systems are failing, costing fishermen an upwards of $100 million annually.
The Chesapeake Bay Foundation offers citizens to fund and support local ecosystems that have a global difference. Donating money to this organization can go a long way. One way is to either become a member or even volunteer to fight the ongoing ocean acidification problem. Scientists are currently in the process of adding pH, oxygen, chlorophyll, and tributary sensors to existing systems to have a more accurate and precise study the changes of ocean acidification. On a smaller scale, scientists are using an oat-ton waterproof pH 150 meter and a X-Tech CO2 100 CO2 monitor. The University of Alaska has the top of the line scientific research regarding ocean acidification. They have measured the pH level of the surface to an average of 8.21 at the beginning of the Industrial Revolution to about 8.10. This research concludes to an estimate of 0.3 decrease in pH level by the year 2100.
Transportation is a huge concern for ocean acidification. Driving less or public transportation would be ideal, but not realistic. People can make a difference by keeping their tires properly inflated, getting their cars serviced regularly, and by choosing fuel-efficient cars. Human actions have accelerated ocean acidification, but humans can also slow down the process with effort. There are many things an individual can do in the community or on a global level that can help curb the effects of ocean acidification, such as using and creating energy more efficiently so there's less CO2 being released into the atmosphere, and by protecting marine habitats and wildlife so that the ocean can bounce back from the damage that has already been caused due to ocean acidification.